One model may make a wrong prediction, but if you combine the prediction of several models into one, you can make better predictions. This concept is called ensemble learning. Ensemble are methods that combine multiple models to create more powerful models. Ensemble methods have gained huge popularity during the last decade. There are two important ensemble models which use decision trees: random forest and gradient boosted. In this video, I'm gonna talk about random forest. First, I'm gonna cover what random forest is. Next, I'm gonna mention some advantage and disadvantage of random forest. Finally, I'm gonna show you how to implement random forest with a real world dataset. Let's dive into what random forest is. You can think of random forest as an ensemble of decision trees. The decision tree models tend to overfit the training data. You can overcome the overfitting problem using random forest. To implement random forest, we need to build many decision trees. A random forest consists of a collection of decision trees. Each tree random forest is slightly different from the others. These trees use a different subset of features. Note that these features are randomly selected. When making the final predictions, the predictions of all trees are combined and these predictions are averaged. Since we use many trees, we can reduce the amount of overfitting. Let's take a look at some advantages and disadvantages of random forest. First, I want to talk about some advantages. You can use random forest for both classification and regression tasks. Random forests often work well without heavy tuning of the hyperparameters. You don't need to scale the data. Random forest may provide better accuracy than decision tree since it overcomes the overfitting problem. There are some disadvantages of random forest. Let's take a look at disadvantages. Random forest cannot be performed well on very high dimensional and sparse data such as text data. Random forest is not simple to interpret since it uses deeper tree than decision trees. So, we saw some advantages and disadvantages of random forest. Now, let's go ahead and take a look at how to implement random forest with scikit-learn. To show how to implement random forest, I am gonna use the breast cancer Wisconsin dataset. Before loading the dataset, let me import pandas. Import pandas as pd. Let's load the dataset. df equals pd dot read csv. Let me write the name of the dataset. Breast cancer Wisconsin .csv. Cool! Our dataset was loaded. You can find the link to this dataset in the description below. Let's take a look at the first 5 rows of the dataset. df.heat. Here you go. This dataset consists of example of malignant and benign tumor cells. The first column in the dataset shows the unique ID numbers and the second column shows diagnosis. Let's say M indicates malignant and B indicates benign. The rest of the columns are our features. Let's take a look at the shape of the dataset. df.shape. You can see the number of the rows and the columns. Now let's create the input and output variables. To do this, I'm gonna use the log method. First, let me create our target variable. Y equals df.log colon comma. I'm gonna select diagnosis column. Diagnosis. Let me convert this variable into a numpy array. To do this, let me write values. Beautiful. We create the target variable. Let's create our feature variable. To do this, I'm gonna use the drop method. X equals df.drop. Let me write the column names that I am not going to use when building the model. Let me set diagnosis and ID. Lastly, let me set unnecessary column. Unnamed colon 22. To drop from columns, let me set axis equal 1. To convert a numpy array, let me set values. Cool! We have created our variables. Note that our target variable has two categories, M and B. Let's encode the target variable with label encoder. First, I'm gonna import this class from sklearn.preprocessing import label encoder. Now I'm gonna create an object from this class. le equals label encoder. Let's fit and transform our target variable. Y equals le dot fit transform. Let me set y. Awesome! We encoded target labels. Before building the model, let's split the dataset into training and test set. To do this, I am gonna use the train test split function. First, let me import this function from sklearn model selection import train test split. Let's split our dataset using this function x train x test y train y test equals train test split. Let me set the variables x y. To set imbalanced, let me set stratify equal y. For reproducible output, let me set random state equal 0. Cool. To use random forest in scikit-learn, we need to import random forest classifier from ensemble module. Let's import this class from sklearn dot ensemble import random forest classifier. Now I'm gonna create an object from this class rf equals random forest classifier. First I'm gonna use default values. Only I'm gonna set the random state parameter. Random state equal 0. Cool. We created an object. Let's build our model. To do this, I'm gonna use the fit method with training set. rf.fit x train y train. Awesome. Our model is ready. Let's evaluate our model using the training and test set. Y train pred equals rf.predict x train. After that, y test pred equals rf.predict x test. Cool. We predict the training and test values. Now let's take a look at the performance of our model on datasets. To do this, I'm gonna use the accuracy score function. First, let me import this function from sklearn matrix import accuracy score. Now let's take a look at the accuracy scores for the training and test set. rf train accuracy score y train pred. After that, rf test accuracy score y test pred. Now let's print these scores. Print f quotation marks random forest train slash test accuracies colon curly brackets rf train colon. To see only the first 3 digits, let me set dot 3f slash curly brackets rf test colon dot 3f. Awesome. The scores were printed. As you can see, the score on the training set 100% and the score on the test set is 95%. This means that the model has the overfitting problem. Note that this random forest model learned the training set so well, so it simply memorized the outcome. But the model cannot generalize. To overcome the overfitting problem, we control the complexity of the model. To do this, we need to tune the model using different parameters. To build a better model, I'm gonna use grid search technique. Let's import grid search from sklearn dot model selection import grid search cv. Now I'm gonna create an object from random forest classifier. rf equals random forest classifier. For the random state parameter, let me set 0. Okay, now let me create a parameters variable which contains the values of the parameters. Parameters equals curly brackets. For the maximum depth of the tree, I am gonna use the max depth parameter. Max depth colon square brackets 1, 10, 20. If you want, you can write more values. It's enough these values in our case. To build a random forest model, you need to decide on the number of trees. Now, I'm gonna create the values for an estimator's parameter. An estimator specifies the number of trees in the forest. For this parameter, I'm gonna use for loop in list. And estimators colon square brackets e4 e in range 10 comma, 100, comma, 10. Let's set values for the mean leaf size parameter. This parameter uses to specify the minimum number of samples in a leaf node. For this parameter, I am gonna use for loop in list again. Mean samples leaf colon square brackets e for e in range 1 comma 10. Now I am gonna specify criterion parameter. Here I am gonna set two parameters. Criterion colon square brackets Gini and entropy. Lastly, I am gonna write how to select the features. A critical parameter in the random forest technique is max features. You use this parameter when looking for the best split. Let me write three values. Max features square brackets auto sqrt and log2. Awesome! We specified the values of the parameters. To find the best parameters, I'm gonna create object from grid search. CLF equals grid search CV. First, let me set the estimator RF. Next, let me set the parameters variable. Parameters. To use all processors, let me set n jobs -1. Beautiful! Our model is ready to train. Next, I am gonna fit our model with the training set. CLF dot fit xtrain ytrain. To see the best parameters, I am gonna use the best param attribute. Print CLF dot best params. When we execute this cell, you can see the best parameters. Now, I am gonna predict the values of the training and test set. Note that we don't need to train our model again, because after the best parameters are found, the model is trained with these parameters. So you can directly use the CLF model for prediction. Let's predict the values with this model. To do this, let me copy these codes and paste here. After that, let me copy these codes and paste here. Lastly, I am gonna copy this code and paste here. I am gonna only change the model name CLF and let me set CLF. Here you go. The accuracy score were printed according to best parameters. The performance of the model is better on both the training and test set. Notice that the score of the model on the training set is close to the score on the test set. In addition, both accuracy scores are close to 1. Awesome! So, we have found the best parameters and predicted the values of the training and test set. In this video, I talk about random forest and how to implement this technique with scikit-learn. As a result, a random forest consists of multiple decision trees. This method averages the result of all the trees to output a model. So, you can overcome the overfitting problem with this approach. You can perform both classification and regression tasks with this method. That's it. I hope you enjoyed. You can find the link to this notebook in the description below. Thanks for watching. Don't forget to subscribe to our channel, give a like and leave a comment. See you in the next video. Bye for now.